The more concepts in probability is an and statement. In the English language, and means both things must be true. The same is true in probability. If you say that you want an event that contains country songs and songs about cats, then the songs included must be about cats and must be country songs. Or statements in the English language, or means that one thing or the other thing can happen, but not necessarily both can have to happen. With or statements, you can have both things happen too, but that is not necessary. The same is true in probability. If you say you want an event that contains country songs or songs about cats, then the songs included can be about cats, could be a country song, or could be a country song about cats. There are several ways to display probability situations. These ways are a tree diagram, a Venn diagram, and a two-way table, though creating a two-way table will not be discussed. Because you need technology to do that. So it's a little bit more work than we want to do. So in a tree diagram, one branch for the first choice, and then there are other choices. Then one branch for each of the first choices to the second choice, and so on. One branch can be a list of the probabilities for each choices. With and statements, you multiply probabilities you travel from the start to the last choice on a particular branch, or statements are where you add the probabilities of each branches to the probabilities of the next branch. So let me just kind of show you what one looks like. So we'll go to an example to help you with this. So Nolan Ryan has an overall record for the most no-hit games. Ryan mostly threw a fastball and a curveball. In fact, 80% of the time, Ryan threw a fastball, and about 20% of the time, he threw a curveball. For a batter against Ryan's fastball, their batting average was .200 or 200, which means that they would hit the ball 20% of the time. With the curveball, the batting average was .150, which is a probability. What is the probability that a batter would hit the pitch? To answer this question, it's helpful to draw a tree diagram. To draw a tree diagram of this situation, the first choice is the type of pitch. It can either be a fast or a curveball. Draw an arrow from the start for both of these choices. All right, so here's the start with our pitch. And again, he can either do a fastball or a curveball. 80% of the time he did a fastball, and 20% of the time he did a curveball. Then what can happen? After the choice is the choice that the batter hits the ball or misses the ball. So it's not really a choice, but they can either hit or they can miss. They can either hit or they can miss. 20% of the time they hit the fastball. That means 80% of the time they miss the fastball. 15% of the time they hit the curveball, which means 85% of the time they miss the curveball. Now, if you'd like to find the probability that they actually hit the ball, you will come down the tree from pitch to the fastball. So that'd be 0.8 times 0.2, because you have to have the fastball and hit it. So you're going to multiply those together. plus, because you came back to the start, so we're going to add in. So this was my and statement of multiplying these two ands together. Coming back means, or they could have gotten a curveball. Or means you're going to add them and you're going to come back to the start. You can do 20% of the time you have a curveball and you hit those 15% of the time. And now all you do is just multiply these together to find out what your chances are that the batter actually would hit the ball. And those probabilities, or that multiplication, is going to be 0.8 times 0.2, which is 0.16, plus 0.2 times 0.15, which is 0.03, is equal to 0.09. I'm sorry, 0.19. So very small chance that somebody actually would hit the ball.